Hey everybody, so in this video we're going to talk about the rest of section 5.1 for modeling functions and graphs about inverse functions. Okay, so I'm expecting that you've already seen the first video on this section. You already know what an inverse function is and you've seen some examples. Okay, so what we're going to talk about first is finding the equation of an inverse function. Okay, so let's talk about the steps to do that. Okay, so this is assuming that you're given the equation of the original function. Okay, so the first step is to change out of the function notation into x and y notation. Okay, this just avoids any confusion between the f of x notation and actual x. Okay, then we're going to go ahead and isolate x. Okay, some people might say solve for x. Okay, then we're going to go ahead and go back to function notation. Okay, so we're going to change x into f inverse of y. Okay, and then the last step, and this is only if you're specifically asked for f inverse of x, okay, you can change variables to f inverse of x. Okay. All right, so let's look at an example. Okay, so we're going to start with an example that's not too tricky. So we have f of x, okay, is x plus 2. Okay, now we conceptually know that this function takes a number and adds 2. Okay, and we should also understand conceptually that the inverse of that operation would be to subtract 2. Okay, so hopefully we're going to end up with the solution being the function that takes a number and subtracts 2. Okay, so we're going to do as the steps suggested and exchange f of x in for y. Okay. And now we're going to isolate x. So we want x to be our variable that's alone. Right now we can see that y is isolated, but we're going to try to isolate x. So I'm going to go ahead and subtract 2 from both sides. Hey, buddy. Okay. And then we can change back to function notation now that we have x isolated. So I'm going to change from x. Okay, I'm just going to write it like this really quick. Okay, the traditional output on the left, input on the right. And then I'm just going to change back into function notation. F inverse of y is y minus 2. Okay, I like this F inverse of y notation because it reminds you that the inverse function is taking in y values and outputting x values. Okay, now if you are asked specifically for F inverse of x, you can always just make a change of variables and change to F inverse of x is x minus 2. Okay? So if it specifically asks you for F inverse of x, then you can always change variables back to x. Okay? Let's see another example. Okay, so Okay, so this is just a little bit more complicated. In this function does two different things. It multiplies by 3 and then subtracts 2. So the opposite of that should be to add 2 and then divide by 3. Okay, so let's make sure that this lines up with what we're thinking. Okay, so first we're going to change into the x and y notation. Okay, and now we're going to isolate x. So I'm going to add 2 to both sides. Okay, and then I'm going to divide both sides by 3. Okay. All right. Now I can change back into the function notation if I want. So this would be f inverse of y is equal to y plus 2 over 3. Okay, and this function does exactly what I described at the beginning, right? The opposite of multiplying by 3 and then subtracting 2 should be to first add 2 and then divide by 3. Okay, all right. Let's do one more example of this. Okay, so first we're going to change for x and y notation. Okay, and now we're going to try to isolate x. Now in order to isolate x here, okay, we're going to go ahead and multiply this equation on both sides by x. Okay, now here this x is going to cancel with this one. Okay, so on the left side, I'm going to get xy, and on the right side, I'll just have 3. Okay. Now remember, we're trying to isolate x, so I'm going to get rid of this y by dividing it to the other side. So I would get x equals 3 divided by y. Okay. Now I can change to inverse notation, h inverse of y equals 3 over y. Okay. Now I actually just realized that in my previous example I had a mistake. The original function was g, and when I changed to inverse notation I changed it to f automatically, but this should be really g inverse of y, right? You want to match the notation from your original question to the notation in your answer. I'm sorry about that. All right. So that is how you find the equation of the inverse if you're given the equation of the original function. Okay, now let's look at, let's look at how you can find the equation or the graph of the inverse function if you're given the graph of the original function. Okay. So the first thing we're going to do is just graph a couple of functions and what we know are their inverses. Okay, so we're going to do a couple examples of things that we know for sure are inverse functions. Okay, so we have the very first thing that we talked about and also the first functions from example 1 where we had x plus 2, okay, and then its inverse function x minus 2. Okay, so let's go ahead and graph these on the same graph here. Okay, so this has a slope of 1 and a y-intercept of 2. Okay, so I'm going to go ahead and mark this at 2. Then my slope goes up 1 and over 1. Okay, so I'm going to go ahead and graph my function here. Okay, and then I'm going to graph my inverse function. So my slope is 1 and my y-intercept is -2. So I'm going to start at -2, 0, go up 1 and over 1. Okay, so you can see that these graphs are similar, but it's hard to know in what way they're similar. Okay, All right, let's do another example so we can see how the graphs are really connected to one another. Okay, so we're going to go ahead and do the example from part B in the previous example, which was g of x is 3x minus 2, and g inverse of x is 1/3 x plus 2/3. Okay, so we're going to go ahead and graph these two. Okay. All right. So I'm going to start with this one. Okay. So my y-intercept is at 0, -2, and then my slope is 3. So I'm going to go up 1, 2, 3, and over 1, or down 1, 2, 3, and left 1. Okay, and I'm going to connect these for my graph here. Okay. And then for my inverse function, I can see that my y-intercept is 0, 2/3, so that's going to be here. And then my slope is 1/3, so I'm going to go up 1 and over 1, 2, 3. Okay. Okay. So again, you can see that these graphs are related, but not really in what way they're related. Okay. Now, the last graph I want to do before I kind of reveal how these graphs are related is one of our base graphs, okay, that we also said we know are inverse functions. Okay. So we'll do the original function being x cubed. This is one of our base graphs, and its inverse function, right, the opposite of the cube is the cube root. Okay, so since these are both base graphs, we should be able to sketch them pretty easily. Okay, all right, so we're going to sketch the original graph. Okay, my key points are 0, 0, 1, 1, and -1, -1. Okay, and my graph has this characteristic S shape like this. Okay, then I'm going to graph my inverse function, okay, which has the same key points and has this distinctive shape. Okay. All right. Now I want to draw in one thing that will hopefully help us see how these things are related. Okay, so we're going to look at the line y equals x. Okay. So as we look at this line y equals x, right, you can see that these two graphs look like mirrors of each other across this line. Okay, let's look at our other two graphs. Okay, so we're looking at this graph here. You can see again that they're mirror images across this line y equals x. Okay, and our last graph, graph B, when we look at the line y equals x, okay, it's going to look like this. Okay, where again we can see that they're reflections of one another across the line y equals x, right? This point is going to be reflected up here. This point is reflected here. Okay, so, oh, I'm sorry, that point would be reflected like over here. Okay, so this point's reflected here. Okay, you can see some of the reflected points. Okay, so what I'm trying to get at here, and what hopefully you can see from these examples, is that a function and its inverse are reflected across the line y equals x. Okay, so oops. Okay, so let's go ahead and look at an example where we have the graph of the original function f of x, and we're trying to show the graph of its inverse function. Okay, so I'm going to draw the graph of f of x here. Okay, now you may recognize this as the square root of x graph. Okay, now we're going to graph in the line y equals x just so that we have it for reference. Okay, try to graph it as straight as I can. Here we go. Okay, and then we're going to look for points. I'm going to draw this a little bit more curved so you guys can see it separate from the graph. Okay, now we're going to look for points to reflect, and then we're going to reflect across this line. Okay, now this point and this point are on the line of reflection, so they'll also be in our graph for f inverse of x. Okay, now this is the point 4, 2, so it's going to reflect over to the point 2, 4. 1, 2, 3, 4. Okay, so you can see visually how it's reflected here. Okay, now that we've got a couple points for reference, we're going to draw in the shape of the reflected graph. Oops, I don't want it to decrease. It's going to go look like that. Okay, so you guys can see visually how this looks reflected across this graph. Okay, so this is my recommendation for drawing the inverse function. Reflect a couple of points. So we did 1, 2, 3 points here, and then drew in the shape of the graph, but reflected across this line y equals x. Okay, all right, I hope that makes sense, and I will see you guys soon.